we're going to continue looking at linear inequalities, and we're going to move into systems of linear inequalities. So number 1 says, graph the following linear inequality. It's already in slope-intercept form, so we're going to graph this similar to an equation. So we're going to start with the y-intercept, which is +1. So I'm going to put a point at +1, and then I'm going to use my slope to find the next point. So -2, I can write that as -2/1. I need rise over run, so I'm going to go -1, 2, +1 to find my next point. Or I'm going to go up 2 to the left 1. So since this is a positive movement, I have to go negative here. This is negative in the x direction, positive in the x. Up is positive in the y, down is negative in the y. All right, so now that I do that, I'll look at the inequality, and it says less than or equal to. So the less than or equal to, so that tells me that I'm going to have a solid line here, and less than, the slope of this line is negative. It's going downhill, so less than, in this case, would be this side of the graph. So if you have a pencil, you would just kind of shade all that in. I'm not going to try to shade that in with my pen, but that is the solution set would be all the points in the shaded region for that inequality. All right, number 2, first we have to put it in slope-intercept form. So remember y equals mx plus b. That means we have to solve for y first. All right, so in order to do this, I'm going to subtract 3x from both sides. And I'm going to bring down my -2y. I'm also going to bring down the greater than or equal to symbol. And I've got -3x plus 8. I'm going to put my slope first. Anything attached to the x, that's going to be my slope. There's no sign there, so I know that's a positive 8. I'm going to divide. Make sure you divide everything by the -2. And also, something that you got to be careful with, don't forget that when you divide or multiply by a negative, you have to switch the inequality. So this is greater than or equal to, this becomes less than or equal to. Only when you multiply or divide by a negative. 2 negatives become positive, and this becomes -4. All right, so I'm going to go down 4. My y-intercept is always on my y-axis. 1, 2, 3, 4. So -4. I'm going to put a point here. And then I'm going to use my slope, 3/2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And that gives me my points. If I look, it is less than or equal to. So again, this is a solid line. Supposed to be a straight line. And then everything below the line, less than or equal to, since this is a positive slope, below is this direction this time. So make sure you graph that as below that line. And hopefully on paper, if you have something, you can make a line a little bit straighter. I'm just trying to give you the basics and move through so we can get to systems of equations. All right, let's look at number 3. So number 3 says identify the linear inequality shown on the graph. Okay, so there's a couple different ways. You can solve each one of these for y and then see which one this is, or you can just pick points. All the points in the shaded region are solutions to this inequality. So if you pick a point over here, it should work for all the ones that have shaded areas in that region. So we may have to pick a couple points to make sure, but that may be easier for some of you guys than solving. So let's see what that looks like. All right, so the first thing I'm going to do is let's pick 1, 1. All right, so if we pick 1, 1, what I'm going to do is just plug it in to see what I get. So I'm going to have 2 times 1. Just plug in the x and y, both are going to be 1. So plus 5 times 1. Is that greater than -5? So that's 2 plus 5 is greater than negative 5. Is 7 greater than negative 5? The answer is yes. That one works. All right, so let's try the second one. So 2 times 1 minus 5 times 1. Is that less than 5? All right, so we got 2 minus 5. 2 minus 5 is negative 3. Negative 3 is less than 5, so that one works too. Let's try the next one. So 5 times 1 plus 2 times 1, is that greater than negative 2? So 5 plus 2 is 7. 7 is greater than negative 2, so that one works as well. All right, the last one, 5 and plug in 1 minus 2 times 1, and then is that less than 2? So 5 minus 2. 5 minus 2 is 3. 3 is not less than 2. That is not true, so this one cannot work. All right, so we eliminated one choice there. So let me erase this, and we'll pick another point. And again, I'm showing you what I'm doing. You may be able to do this a little quicker using just mental math or your calculator, but I want you to know what we're doing, like what the process is. All right, so let's pick a point. Let's say in this quadrant 4. So let's pick, let's see, 1, 2, 1, 2. So let's use 2. X is 2, y is negative 2. All right, so we're going to take and plug in 2 for x and negative 2 for y. And we're going to say if that equals. So that's going to be 4 minus 10. 4 minus 10 is negative 6. Negative 6 is not greater than. Negative 6 is not greater than negative 5. All right, so we can mark that one out, and let's try the next one. So we've got 2 times 2 minus 5 times negative 2. So that's going to be 4 plus 10, or 14. 14 is 14 less than 5. 14 is not less than 5, so that doesn't work either. So we'll try the C. 5 times 2 plus 2 times negative 2. So that's going to be 10 minus 4, 6. Is 6 greater than negative 2? Yes, it is. So we had to use 2 points to find that, and sometimes you may have to use more points. If you choose points, I would try to spread them out. Pick points in different quadrants or different regions. That way, depending on where the line is. So if you solve this for y and you graph it, you should get this equation, or this line here. And all the points in the shaded region are solutions.